My name is Nick Borson, and this is the second in a two-part series about working with XML using PowerShell. So in the first part, I talked about, first of all, just some background on what XML is, and then I talked about using the select XML commandlet in PowerShell, which is a way of querying XML files using XPath. So as a quick review, XML stands for Extensible Markup Language. It is a text-based markup language for representing data, and it represents that data as a hierarchical tree of elements, as well as other, and elements can also contain other nodes that are just like text nodes and so on. So if you aren't really familiar with XML, I would recommend going back and reviewing the part 1 video, because I'm going to be building on that in this video. I'll include a link in the description. Just to review, XPath is which I covered in that first video, is a query language for XML that allows you to traverse or locate data within an XML document tree, the document object model, in the same way that a file path allows you to locate files or directories in a file system tree. But all of that works with the document object model, in which the entire XML document is read into a tree of objects. But in this video, I'm going to talk about the XmlReader and XmlWriter classes, both of which are part of the .NET framework upon which PowerShell is based. The XmlReader class provides a very efficient way of reading the contents of an XML file, but reading it reading it sequentially without having to read the entire file at once into a DOM, but also reading it in a way that hides all of the nitty-gritty details of XML syntax. So instead of having just raw characters, you have things like XML elements and attributes and so on. So it provides a nice level of abstraction over the nitty-gritty of XML, but still provides an efficient way of reading XML a bit at a time instead of having to read the whole thing into memory at once. XmlWriter is kind of the reverse of that. If you want to have some content that you want to store as XML, you can create an XmlWriter and then write one thing at a time to that XmlWriter, and again it hides all the nitty-gritty details of XML syntax. For example, if you have a special character that needs to be encoded as a XML entity, XmlWriter will handle that for you, and XmlReader will do that reverse translating from character entities into actual characters without you having to worry about those kinds of details. So XmlWriter is going to always ensure that the resulting XML is well formed. It conforms to the syntax defined by the XML specification. Whereas if you were just going to write XML as text yourself, there are a lot of things you'd have to deal with yourself to make that happen. A sample XML file, the same sample XML file that I used in the part 1 video, and this represents a collection of books in a bookstore. So we have a top-level element called bookstore. There's a start tag on line 1 and an end tag on line 22, and then as within the bookstore element, or contained by it, children of the bookstore element are a bunch of book elements. And for example, the first book element has a start tag on line 2 and an end tag on line 5. And each book element has a number of attributes. So the book has a title, author, and format. These are all attributes. And then each book element also has child elements. There's a series element and an inventory element, each of which in turn has attributes. The series and inventory elements are both empty elements, as denoted by the slash before the closing angle bracket. And that means they don't have an end tag. They don't have any child content, and they don't require an end tag. Okay, so that's our data that we're going to process. Now the first script I want to show you is simply creating an XML reader and repeatedly calling read on it and showing you how that reader exposes that XML content to you as the user of this class. So first of all, we construct the file name by using the join path command. So we join the PS script root variable, which is always the directory that contains the script, with the file name, and it gives us the full path of the file we want to read. Then we construct the XmlReader object. So inside the square brackets here is the type, system.xml.xmlReader. And the XmlReader class has a static method called create. So we invoke that method by having the type name in square brackets, followed by colon, followed by the method create that we're going to invoke. The parameters of that method are in parentheses, so we have the file name we're going to create the reader from, and then the other two parameters are optional, so I'm just passing null for those. You can always look up, if you want the details of the XmlReader create class, you can just look up xmlreader.create using your favorite search engine, and you'll find that there are a few different overloads of that method, but this is sufficient for right now. This one will create an XmlReader object that reads this particular file. Now, when we first create the reader object, which by the way we've now assigned to a variable, when we first create this object, the reader is positioned kind of at the beginning of the file, before the first node of the file. At any given time, the reader has a node type, which tells you what the reader is currently positioned on. And each time you call the read method, it advances to whatever the next node is. That node could be a start element, an end element, a text node, a white space node, or what have you. It advances to the next node element and returns its type. When you reach the end of the file, the node type will be none. So for our script here, what we do is we simply call while. We have a while statement. This will execute the code block that is in curly braces here repeatedly as long as the condition inside the parentheses is true. So on the first time we evaluate this, we'll call reader.read. That will advance to the first node and return the node type. If the node type is none, that is going to be equivalent to false and will fall out of the while loop. If it's anything else, we execute the loop body, and so we write the output, we write the node type, and then we write the local name of the node. Now we're using string interpolation here. We have the inside the double quotation marks, the $ left paren, everything up to the left paren, up to the matching right paren. The interior of this is evaluated as an expression and inserted in place of that into the string. And likewise here, inside the $ parentheses, we evaluate this expression and insert that in place of the string. So that's the output we write. And at the end, and once we reach the end of the file, then node type will be none, and we'll fall out of the while loop and execute line 7, where we close the reader, and finally we exit the script. Closing the reader, by the way, it just ensures that the file is closed promptly. If we didn't call close, it would eventually be closed once the reader object is freed up by the garbage collector, but calling close is good form just to ensure that the file is definitely closed when we reach this point of the code, as soon as we're done with it. So let's go ahead and run our script. So we had test reader, and we see that for each iteration of the loop, we output, remember, the node type and then the local name. So the first node we read is a element node, so that's the node type, and the local name is bookstore. So this is corresponding to the start tag for the bookstore element. Then we have a white space node, and then we have another element. That's the start tag for the first book element. Then we have more white space, and then we have the start tag for a series element. So this is a child element of the book element, and so on. Now all this white space is present because of the fact that our XML is nicely formatted by having, we have a new line here, and we have indentation. All that is white space. So we don't really care about the white space for purposes of it's not really significant to the content or the data that we're interested in, but it is still there. It's exposed by the reader. What we can do is, if we want to ignore the white space, we can say reader move to content. So this is a method on the XmlReader class that, as long as we're positioned on some non-content type of node, such as white space or processing instructions, things like that, it will keep advancing until we either find an element or a text node or something like that, or until we reach the end of the file. So when we call move to content, we skip past all that white space. Now, move to content returns the node type of whatever element we end up on, and I don't want to output the node type, so I'm going to redirect the output to out null. That ensures that we don't output that to the console. And then we'll just write the output as before. So if we run the script again, we get a little bit cleaner output. So now we have the first element, we have the start element, the start tag for the bookstore. We have the start tag for the first book, so this will be a child of the bookstore. Then we have the start tag for series, which is an empty element. We don't really know that from this particular output, but we can find that out later, as we'll see. We have the inventory element. Then we have an end element for the book, the end tag for the book element. So this book end tag matches this corresponding start tag. So everything from here to here is the book element. But of course, the XML reader just returns one tag at a time. You're not reading that whole thing into memory or anything. So you can process that yourself and do whatever you want to sequentially with it. Likewise, we have the second book element, which again, we have a start, the element node, which is a book. We have a couple of series elements, then we have an end element, which is a book. And so on up until we get past the last book, and then we have the end element for the top level bookstore, the end tag for the top level bookstore element. So that's how XML Reader exposes the contents of an XML file for you. And there are more properties of the XML Reader that allow us to then get attributes and things like that. So we will get into that in a moment. Our test reader script again. In this script again, we just read, we constructed an XML reader, and then we just read each node sequentially and output what we saw. So that gives us an idea of what the raw input from the XML reader class looks like. But how would we actually use that in a program? So let's take a look at another script here, which I called getBooks. So this script will process the contents of that XML file and construct an array of book objects. So we define, so first of all, we have here the file name we're going to read. This is the namespace URI of all the XML elements in this file. So again, it matches this XML_NS attribute. And then here we define a class. So each book element is going to be converted to an instance of this class. So we're going to assign an integer ID. This doesn't actually come from the file. We're just going to assign the first book ID 1, the second book ID 2, and so on. And then the title, author, and format all come from the corresponding attributes of the book element. The series name and series book fields are going to come from the from the series element, the child series element, and the price and inventory count are going to come from the inventory element. Again, looking back at our data. So the book element, we're going to initialize the title, author, and format. Then we'll read the series element, initialize the series name and series book, and then we'll read the inventory element and read and use the price and count attributes to set those properties. Okay, so here's our book class. Now here's how we read the books. So we have a function called getBooks. We construct the XML reader object using the static create method, just like we did before. And then we call another method that I haven't shown you before called isStartElement. So isStartElement, first of all, it implicitly calls move to content for you. So it skips over any white space or processing instruction nodes, things that are not content that we care about. And then once it's reached some actual content, which could be an element, or it could be a text node, it could be an end tag, what have you, end element. Then what it does is if that node is an element, is a start tag for an element, and its name and its local name and namespace URI match the values we passed in, then it will return true. If it's some other element, or if it's a different kind of node than an element, then it's going to return false. So what we're doing here is we're checking whether the very first thing we encounter in this file is the start tag for the bookstore element. If it is, we will enter the body of this if block. Now we say, is this element an empty element? So remember that in XML here, for example, we have an element can have if it has a slash before the closing angle bracket, that defines an empty element, meaning it doesn't have an end tag, and it also doesn't have any child content. So the bookstore element is not an empty element, the book element is not an empty element, but the series and inventory elements are empty elements. So when reading this, we need to distinguish that case. So in this case, we expect it's not going to be an empty element, so we're going to fall into the body of, or into this if block. Now we're going to assign each book object we create a unique integer ID, and we do that just by initializing a variable nextID to 1, and then each time we create a new book, we'll increment that variable. So this is just a little bookkeeping detail to allow us to assign each object an ID. Now we advanced past the start tag of the bookstore. So remember, when we reach this point in the code, we're positioned on the start tag for the bookstore element. So calling reader read will advance past that element to whatever follows it. And redirecting it to out null just ensures that that the node type that's returned from reader read is not part of the output of this method, of this function. Now we're going to loop. Basically, we're going to process all of the book elements that are children of that bookstore element. So as long as the current element is a book element, again, the local name has to match book, and the namespace has to match the namespace that we expect. Then, if that's true, this method is going to return true. Otherwise, it'll return false. So as long as it returns true, we're going to execute this block of code. And during the course of this block of code, basically, we're going to process the book element and all of its child content and advance to whatever comes after that. So the next time we encounter this while loop, we'll then be positioned on the second book element. And the next time we encounter it after that, we'll be positioned on the third book element until we come to something, until we've passed the last book element and we're positioned, we expect, on the end tag for the bookstore. Okay, so we're positioned on the start tag for a book element. We construct now a new object of our class that we've defined above. So we say use the new object command. We specify the type book because that's the name of the class that we created up here, book. So now we have a object of type book which we've assigned to the book variable, and we're going to set some of its properties. So we set the ID to the next ID. Remember, this was the variable we initialized to 0 up above before we entered the loop. Or sorry, we initialized to 1. So now we set that as the ID of this object, and then afterwards, using the postfix operator here, we're going to increment the next ID after we've used its value. So the old value of next ID gets assigned to the book ID, and then we'll increment next ID to 2. Then the next time we create a book, its book ID will be 2, and then we'll increment next ID to 3, and so on. Okay, so that's how we assign a unique ID to each book. Then we set the title to the title attribute of the current element. So remember, the reader is positioned on a start tag. We can call its getAttribute method to get the value of any of that tag's attributes. So we get its title attribute, and we assign that to the book's title property. We get its author attribute and assign that to the author property of the book object, and likewise for format. So we've initialized now the title, author, and format of the book using the corresponding attributes of the book start tag. Okay, now so we're positioned on the book element. Now we want to know, does the book element have any child elements? Of course, they do, but what if they didn't? If they didn't, we would just, if we had an empty book element, we would just fall through to here and advance past the empty element. But assuming the book element is a non-empty element, then we call read to advance past the start tag. Again, redirecting the output to out null so that we don't include the node type in our output of this function. And then, if we have a series element, we expect that the first child element of the book is a series element, but it's optional. So if the series element is not present, we'll just skip it. But if there is a series element, then we initialize the series name property of the book to the name attribute of the series element. We initialize the series book property of the book to the book property of the series element. And then we call another method that I haven't explained before called skip on the reader. So skip will advance past the current element and any child elements it has. So if the current element has child elements, it will not just, it will skip past the start tag plus the, everything contained within that up until the end tag, the corresponding end tag, and advance past that. So skip saves us a lot of trouble of having to deal with the fact that, well, maybe it's an empty element, maybe it's not, or whatever. It always advances past the current element and all of its content. Okay, then we do the same thing for inventory. Again, if we have an inventory element, then we're going to get the price and the count, and we'll assign those to the corresponding properties. Then we skip the inventory element and all of its content, if there is any. And finally, we now should be positioned on the end element, or the end tag of the book element. So we call read end element. This is basically going to, this is sort of an assertion that we expect to be positioned on an end element, and then we advance past it. If it is not if what we have if the current node is not an end element, then this method will fail with an error. Okay, so that was the case where so we've now read the entire contents of the book element, including all of its child elements and its end element. Here we are. So we should be positioned sort of one past the end of the book element, one past and of course if the book element was an empty element, we go to the else block, and so again we should be positioned just past the book element. Then we call move to content, which will skip past the any white space or what have you. Again, redirecting the output to null. And finally, we call write output book. So this is actually producing saying that the output of the function is whatever the book includes, whatever the book object is we just created. So the function output will be a sequence of book objects. So then this right here is this closing brace is the end of the while loop that was executed once for each book element. So when we reach this closing brace, the flow of control will go back to the top of the while loop, and we'll check whether the next thing that the reader is positioned on is another book element. And if so, we'll repeat that whole process, constructing another book object. If that is not the case, then we will fall out of the while loop and okay, so this was the end of the while loop, line 64. We'll fall out of the while loop, and then we expect that we should be positioned on the end tag for the bookstore element. So again, we call read end element, which is our way of saying, hey, we expect the next thing to be an end element, advance past that. And finally, we should be at the end of the file, and so we call reader close. Okay, that was all rather complicated, but let's go ahead and run our script and see what happens. So we call get books. And we see that, in fact, the output of the function is a sequence of book elements. And each book element is formatted in list form as a set of properties. So we have, for each book, we have an ID property, and those are just assigned numerically, sequentially, using what we did in the code. And then each book has a title, an author, a format. These are all constructed from the corresponding attributes of the book start tag. And then we have, for each object, we have a series name and a series book. These are constructed from the series child element. And then we have a price and inventory count that we constructed from the child series element, or sorry, inventory element. So that gives you an idea of how to use an XML reader to parse the content of an XML file. Okay, so we've now demonstrated how we can use XML Reader to read the contents of the XML file and create an array of objects. So we've defined our own data model, if you will, our own set of classes to represent the data in our program. And we've written some code to convert from an XML representation into whatever the class representation we want to use in our program is. Now let's try this. Let's build on this a little bit. I've created a little PowerShell module called Books1. So first thing this does is it invokes the script that I just showed you. So it invokes getBooks to create an array of book objects, and assigns that to the book list local variable. Now this little dot right here is kind of a little trick in PowerShell. The dot in front of the name of the script means that I'm invoking the script in the current context. That means all the variables and methods defined inside this script, instead of being local to the script, they're actually going to be as if they were defined in the script that I'm invoking it from. So that means that, for example, the book class and the $NS variable and so on, those are all actually defined, included here as if we had directly included them in the script. Anyway, so now we have this book list variable, which is our array of book objects, and defined a couple of functions in our module. Again, it's a module, so it has the PSM1 instead of the PS1 extension. And each of these functions is then exported. So we export the find title function, and we export the find author function. So the find title function takes a string parameter, and which is the pattern that we're searching for. And then we just take the book list, and we pipe that, take that array of book objects, the book list, pipe that to the where object commandlet, which will execute the this script block once for each book object. And then, well, actually, it's not that it executes the script block, it evaluates the expression inside the script block. And so as long as that expression is true, then it will be included in the output. So this expression now is using the pipeline variable $underscore, which is going to be the current book object. We're going to get its title property, and then we use the like operator to see if that title matches the pattern. The like property does a very simple form of pattern matching. It's a little different than the match property. The match property, which I've discussed in my previous video about PowerShell regular expressions, the match property does a regular expression match. Like just does a very simple pattern match, similar to what you get if you're using the ls command or the dir command with files, where you can use the star character as a wildcard that matches any sequence of 0 or more characters. You can use the question mark character to match any one character, but it's much less complicated and also but easier than regular expression syntax. So anyway, so like is it does a simple form of pattern matching, and again we export we say basically if the title is like the pattern that the user passed in, then we'll include that in the output. And likewise for find author, we say if the author is like what the user passed in, we'll include that in the output. So let's see how that works in practice. So I will say import module book books1. Okay, so now we've executed the code at the start of the module, we've initialized this book list variable, and then these two functions that we've defined are now visible to us, available for us to use because they are exported by that module. So we can say find title, and we can say stone for example, and this will match any book object whose title consists of any sequence of characters ending in stone. So we find that we have Harry Potter and the Sorcerer's Stone ID 1, and we have, again, Harry Potter and the Sorcerer's Stone ID 2. We have two books with this title because one of them is a hardcover and one of them is a paperback. And likewise, we can say find author, and we'll look for anything that contains the word Tolkien. So the stars, again, are wildcards that match any sequence of 0 or more characters. And we find that we have two books with author Tolkien, and so we output those. Okay, so there's a very simple script that builds on our ability to read from XML into a set of classes, a set of objects. So I have a slightly more complex version of that script that I will show you in a moment. It's a slightly more complicated script that builds on the one I just showed you. So again, we invoke the getBooks script, and we also import all of its definitions into the current context by using the dot, the period here. And we have then we have our resulting book list, which is our array of book objects. And again, we have our find title method, which is exported, and our find author method, which is exported. And I've added one new method called getBook. This takes the integer ID, which is the ID property of the book object, and we just return the actual book from our book list array. Now, if you remember, the integer IDs we assigned starting with 1 and counting upward, but array indices start at 0 and count upward, so I just subtract 1 from the ID to get an array index, and that is how I return the corresponding book. Then I have a function called SaveBooks, which is actually going to use the XmlWriter class to write our book list to an XML file. So the inverse of what we did when we read the XML file. So before going into the SaveBooks method or function, let me just demonstrate how we might use our getBook method. So once again, we'll do find. Well, first of all, we have to remove our books 1 module that we loaded before, and we will import module books 2. Okay, and then once again we can say find author star Tolkien, and then we can say get book 5. And then we see that we have the actual book object. And since what we get back is the actual object, we can modify properties on that object. I can say get book 5, and then if I wrap that in parentheses, well, actually, let's just assign it to a variable. We'll say b equals get book 5, and then b dot inventory count is 2. But maybe I've acquired some additional books. An order came in, and I've got 10 more books. So I'll say inventory count plus equals 10. And then if we say get book 5, we'll see that, in fact, the inventory count is now 12. So if we, in a situation like this where we've just modified the inventory count, this is where having our SaveBooks method comes in handy. So let's go ahead and invoke that before I show you the code. SaveBooks. And now we'll see if we go back to our code editor, we see that we now have a books2.psm1, or data2.xml, which is the file name we read, now shows a count of 12 for that object. And we have the backup file that we created is the original file, which still has a count of 2. So the backup file and the new file are the same except for the inventory count for the 2 towers. So let's go ahead and look at our code that wrote that file. So here's our SaveBooks method. So we start by writing to, and this is a common technique that you can use to avoid potentially losing data. Instead of writing directly to the original file, I write to a temporary file. So I take the file name, I append .tmp to the file name to create a temporary file name, and that's the one we're going to write to. And at the very end of the function, I'll skip over that stuff. At the end of the function, we rename the original file to whatever its name was, .bak, and then we rename our temporary file to the original file name. So this is how we avoid, if something crashes, if there's an error in writing the file, we don't lose the original file. We sort of write our changes to a temporary file and then swap that with the file we want. Okay, so we created a temporary file. Now, before creating an XmlWriter, there is an optional parameter you can pass in called XML. That's the XmlWriter settings. So we create that object, and the reason I created an XmlWriter settings object is because I want to control a couple things about the output. I set the indent property to true because I want that nice formatted look for making it more readable. And also I set the omit XML declaration property to true just because it's optional and I just want it to look more like the original file. Okay, so we create this settings object. Again, this is optional. And then we create an XmlWriter by calling the static create method on the XmlWriter class. So the XmlWriter class is in the system.xml namespace. So we reference the type inside square brackets, and then the double colon, and then the static create method. Then we pass the name of the file we want to create, and we pass the settings object. And then that returns a new XmlWriter object, which we assign to our variable, which we call writer. Again, with the $sign in front for the name of a variable. Now, there are other ways of creating an XmlWriter. You can always look up the documentation for system.xml to XmlWriter on the web, and you can learn what the other ways are. It's just a .NET framework class. And like any .NET framework class, we can call it from PowerShell. Okay, so the writing is actually generally simpler than reading because we can sort of control our we don't have to deal with whatever input we might encounter. We just iterate over the objects we have. So we start by writing the start element for the bookstore, and we include the local name of the element and the namespace URI. Now there is an overload of this that doesn't take a namespace, so if you're not using XML namespaces, you could call that method. And then for each book in our array, our book list array, we want to write an element for that. So what we do is we take our book list array, we pipe that to the for each object commandlet, and then this code block inside these curly braces will be executed once for each book object. So the $_ variable is going to be the book object in question. So we start by writing the book start tag. Then we write the attributes associated with that start tag. So remember, the title, author, and format are all attributes of the book tag. So we simply call the write attribute string to write each of those values. Then if the book is part of a series, so we have if the series book property is not equal to 0, then we know that we had a series element. So if the book is part of a series, then we're going to write a start element for the series. Then we write the two attributes that go with that element. And then we write the end element for the series. And then we assume every book is going to have an inventory element, so we write its start element. We write the price and count attributes, which are associated with that element. And then we write the corresponding end element for the series. And finally, we've written both of those child elements, and so we now write the end tag for the book element itself. Then we reach the end of this block, and so we are going to go back. We finished writing one book. Now we go back and execute the block again for the next book, and so on until we've written all the elements of all the book elements in the array. And once we're done with that, we fall out of this loop. We write an end element for the bookstore. So this write end element line on line 59 corresponds to the write start element on line 28. And when we've done that, we call writer close. This ensures that the file is closed promptly. So rather than just waiting for the object to be eventually cleaned up by the garbage collector, we close it right away. And that way we can rename the file, we can delete the old file, and so on. We don't have any open files hanging around. And then we do what I described before, where we rename the old file to give it with the BAK extension. And the force means that we allow this command to succeed even if there's already a backup file, so we overwrite any previous backup file. And then we rename the temporary file that we just wrote to the original file name. And finally, of course, we export this module member, which is why we're able to call it from the command prompt after we've imported the module. So that is how we write XML using the XmlWriter class. Now, the XmlWriter class saves us a lot of work that if we were just writing using a text file, we'd have to do ourselves. We'd have to ensure the proper syntax for escaping special characters and so on, and it even allows us to do the pretty indentation and so on that we would not get by ourselves. So it's a lot simpler to write XML, and it guarantees that the resulting XML, using this than using just like writing raw characters. And it guarantees that the XML is well formed and conforms to the XML specification. So that is XmlReader and XmlWriter. XML is a very versatile and widely used way of representing data in a human readable form, and it allows PowerShell and the .NET framework generally provide a lot of facilities for working with XML. In part one, I showed you how to access XML, how to read XML using Select XML, which uses XPath queries to extract XML data using the DOM from a tree, which is a tree of objects that can be created from an XML file. And in this video, I've explained how to use these lower level .NET classes to read and write XML, and you can then take that XML and build up your own object model to represent the data that you're interested in. The nice thing about the XmlReader and XmlWriter classes is they're very efficient. They don't use as much memory because you don't have to read the whole XML file into memory at once. There's no DOM that gets created. Under the hood, the DOM stuff is all built on top of XmlReader and XmlWriter. And all of these allow you to work with XML without having to get into understanding or worrying about the nitty-gritty of getting correct XML syntax. That's all handled for you. So I hope that you find this video helpful in working with XML using PowerShell. Thank you.